Hi, this is the first of a series of videos on algebraic fractions. The first topic we're going to look at is how you simplify algebraic fractions. Now, simplification means, let's look at a numerical one first. It means cancelling down a factor on the top line that also appears on the bottom line. And you well know here that, well, how do you write this? You sometimes write this as 2 into 6 goes 3, 2 into 8 goes 4, something like that. But I'd prefer thinking 6 has factors 2 and 3, 8 has factors 2 and 4. Now, the term factor is going to be absolutely vital to us. And notice that when you multiply two numbers together, each of them is a factor. So 2 is a factor of 10, 5 is a factor of 10. If you write 10 as for instance, a sum, then these are not factors of 10. 3 is not a factor of 10, neither is 7. So an addition or a sum will not give you factors. It has to be a multiplication to get factors. Now, when we reach the algebra stage, that's absolutely the same. A factor of a, b, or a times b is a, and another factor is b. So numerical results lead directly to the algebraic results. And where we have an algebraic result, if we replace this by numbers, 2 times 5 for instance, then we get something that makes sense. 2 is a factor of 10, 2 times 5, and 5 is a factor of 10, 2 times 5. So here we have factors 2 and 3 of 6. We have 8 written, factors 2 and 4. 2 appears top and bottom. We can cancel that factor or divide the top by 2 and divide the bottom by 2. 2 into 6 goes 3, 2 into 8 goes 4. Easier to think, let's cancel that factor out. Now I prefer doing this, as you'll find out later why, but 6/8 is the same as 3/4. Now we could, for instance, in a similar way, look at the fraction AB over AC. And if we're comparing the numerical case above, A would be 2, B would be 3, C would be 4. It's just the same, except we have letters instead of numbers. And again, divide the top of the fraction by A and divide the bottom of the fraction by A. And this common factor that appears in the bottom and top of the fraction disappears in effect. So we get B over C. So we've cancelled this factor of A that appears in the top. But remember, do not, under any circumstances, do the same when you have additions. There's the fraction 3/4. And if we tried to do the same, we would get 3/4 equals 2/3. Neither of these are factors because it's sums. It always has to be products before you can cancel. Another example would be A over A squared, for instance. On the top line, 1 times A. On the bottom line, A times A. There's a factor in common. If we divide the top line by A, we're left with 1. If we divide the bottom by A, we're left with A. So A over A squared is 1 over A. It's the same, for instance, as 3 over 3 squared, which is 9. 1 times 3 over 3 times 3. Divide the top line by 3 to get 1, and divide the bottom line by 3, bottom of the fraction by 3, to get 3. So we've got 3 9s equals 1/3. So here's another example. Let's simplify 8AB over AB squared. So let's first of all look at the factors on the top of the fraction, and then look at the factors on the bottom of the fraction. We can see that there's a b, both top and bottom, so we can divide top number by b, bottom number by b, or cancel this common factor out. There's also a factor of a here and a here. If we divide the top of the fraction by a, well, that'll disappear, and we have to do the same to the bottom. So cancelling these, this common factor of a, what are we left with? 8 over b. So this complicated looking fraction simplifies to 8 over b. Another one, let's have a fairly complicated one. There's 12e squared f squared 2 EF cubed. Now I'm looking at the 12 and the 2, and I know 12 is 2 times 6, so I'm going to be able to cancel off this common factor of 2. There's also a couple of E factors and a couple of F factors. And in the bottom there's one E factor and 3 F factors multiplied. So I can divide top and bottom by F. I can divide top and bottom by F again. I can divide top and bottom by E. And I can divide top and bottom by 2. So all of these common factors to the top and the bottom of the fraction cancel out. Look what I'm left with. 6e, 6 times e, divided by f. So this fairly complicated fraction reduces to that. Now, some fractions look like they're written so that they don't have factors. There is an addition in there. But let's try and put a as 1, say, and b as 3, for instance. This fraction would become 2 times whatever 1 plus 3 is, divided by whatever 1 plus 3 is. Now that's a 2 times 4 over a 4. And we can certainly, there's a 1 times 4, that's what the bottom is, we can certainly cancel that common factor of 4 to get 2 over 1, which is basically just 2. But this factor appears top and bottom to leave you the 2 over 1. So I would think of this as 2 times a factor a plus b. This is just like a single number. Think of it as a single number. And on the bottom line we have the same single number. And of course it will just be 1 times that. So this and this cancels. It's a factor that's in common between the top and the bottom of the fraction, and we get 2 over 1, which is just 2. Another example, m plus n times m minus n over 3 lots of m plus n. So on the top of this fraction there are 2 factors. There's m plus n and there's m minus n. They are being multiplied, so they are the factors. This is one factor, this is another factor. And on the bottom of the fraction we've got 3 times m plus n, and there's a factor. Now the factor m plus n appears top and bottom of the fraction. So we've got m minus n over 3. Now I'll now show you what's a common mistake when you're trying to cancel down fractions. And it's to do with cancelling when you can't cancel. A lot of people in a case like this would say, oh well, there's a common factor, so basically we've got 3 over 1 probably, so it's just 3. Now it's very obvious if you think about this that that's 5 over 2, and it certainly does not give you 3. It's not possible to do this, and the reason is that there's a plus in there, and 2 is not a factor. There is an addition there, so 2 is not a factor in the top of this fraction. If it had been 2 times 2 plus 3 over 2, for instance, then 2 and 2 plus 3, each of these are factors. 1 and 2, each of these are factors because they're multiplied. So divide top by 2, divide bottom by 2, and we'd end up with just 2 plus 3 over 1, which is just 2 plus 3. So that's okay. That works. So something like a plus b divided by a, you cannot do any cancelling in a fraction like that. Don't cancel the a's. And one way to think of that is that you do not have a factor because there is no multiplication there. In a case like a squared plus ab, then again there's no factor there, but there is a common factor. If you know about taking out a common factor, we can rewrite this as that. The two factors are a and a plus b on the top line, 1 times a on the bottom line. So there is a common factor of a, top and bottom. So we divide top line by a, bottom line by a, and you'll get a plus b divided by 1, which makes no difference, so it's just a plus b. So this fraction here reduces to a plus b. M squared minus n squared over m plus n. If you know that there are no factors there, there's a minus and this is a plus here. We aren't looking at two things multiplied on the top line nor two things multiplied on the bottom line. However, the top line is a difference of squares. If you know about difference of squares and factorizing, you'll know that this is m minus n times m plus n. Now, if we're looking at factors, there are two factors on the top. M minus n is one of them, and another one is m plus n. They're multiplied together, but that whole expression is one of the factors. This whole expression is another one. And this is divided by m plus n. Now, to consider that as a fraction, of course, it would be 1 times that. So again, top and bottom now does have a common factor. M plus n will divide top by m plus n. We divide the bottom by m plus n. These two factors disappear. We get m minus n divided by 1, which has no effect. So it's just m minus n. And of course, you'll know too about quadratic expressions. We could have x squared plus 3x plus 2 over x plus 1, for instance. No factors yet in the top line, no factors in the bottom line. This is a sum of terms. But if you know how to factor quadratic expressions, factoring this top expression be x plus 1 times x plus 2, you can check it. Firsts are x squared, outside's 2x, inside's 1x. That gives you the 3x, and the lasts 1 times 2 gives you that 2. So there are now two factors on the top. X plus 1 is one of them, x plus 2 is another one, and there's one factor on the bottom, 1 times x plus 1. So we divide the top expression by x plus 1 and the bottom expression by x plus 1, and we're left with x plus 2 over 1, which is just x plus 2. You may have noticed a slight mistake. This equal sign up here shouldn't be there. This fraction here is not equal to this fraction here. Anyway, that's the end of the first video on algebraic fractions.